Hello. Now we are going to take a look at some division properties of exponents. That's right, division. Multiplication's ugly brother. There are four different sort of properties and ideas that I want to look at here. So getting right in it, kind of the base division property, quotient of powers. So talking about multiplication, if we have two numbers with the same base and we multiply them, we add the exponents. And this is the partner with division. If we have two numbers with the same base, but we are dividing them, we subtract the exponents. So a to the fifth divided by a to the third is equal to a squared. Once again, the bases have to be the same. So 3 to the fifth divided by 3 squared, well, that'd be 3 to the third. Another way to look at this, if we really break it apart, 3 to the fifth is 3 times 3 times 3 times 3 times 3. 3 to the fifth means multiply 3 by itself 5 times. And 3 squared is this. And then on top and bottom, we can cancel out. And I'm left with 3 3's on the top, which is 3 to the third. Okay, so 3 to the third, which if we want to simplify that would be 3 times 3 is 9 times 3 is 27. Over here with our r's, same idea. There are 7 r's up top divided by 5 r's, because again, r to the fifth means multiply r by itself 5 times. Cancel out the common ones, and you're left with r squared, which that is the same we get if we go the shortcut. R to the seventh divided by r to the fifth would be 7 minus 5, r squared. Okay. Assume that a and b are not equal to 0 and simplify this quotient. So just with multiplication, work with each term with the same base, kind of in like partners. So let me erase some of that, get that out. First of all, looking at the a's, a to the third divided by a to the first, because there's an implied 1, that would be a squared. And then b to the ninth divided by b squared is b to the seventh. And voila! A squared b to the seventh would be the simplified version. Moving over to our next idea, power of a quotient. The exponent, the power of a monomial distributes. So here, if I have 3 to the fifth to the fourth power, that means 3 gets taken to the fourth power and 5. 5r divided by t to the fifth power, it becomes r to the fifth divided by t to the fifth. So the exponent distributes to the top and the bottom of a fraction, just like it distributes across multiplication, such as a squared b all to the third power is a to the sixth b to the third. Oh, notice there, remember our power to a power property. If a power gets taken to a power, you multiply it. Okay, so going down here, we're going to keep that in mind. This looks daunting at first as it simplify this big monomial, or not a monomial technically, so simplify this expression and assume that p and q are not equal to 0. Why are p and q not equal to 0? Why do they have to stipulate that? Well, it's because if p or q were 0, you would be multiplying by 0, which means on the bottom you would have 0. So you'd be dividing by 0, and that's an uh-oh, don't want to do that. Okay, so since we are safely assuming they are not equal to 0, we are mathematically safe and with our rules. Okay, simplify this. So I need to distribute my 3 up here to each thing, all 6 of these numbers inside. Okay, let's rewrite it. So I have 3 to the third, but then, okay, I go m to the third power. I'm taking a power to a power, so I multiply m to the ninth. N squared to the third, that becomes n to the 6th. Going down low, 4 to the 3rd. Distribute to all of these terms. P to the 5th to the 3rd. Multiply, so that's 5 times 3, which is 15. And then I have q to the implied first, q to the 1st to the 3rd, so the 1 times 3, q to the 3rd. Okay. Now, I take a look through this. Are any of my bases the same here? M, N, P, Q. No, they're all different, so there's no more simplifying. In fact, between the top and the bottom, there's nothing to cancel out. So no simplifying there. However, 3 to the 3rd, 4 to the 3rd, I can figure that out. So I should simplify a little more. 3 to the 3rd is 27. M to the 9th, N to the 6th. And then I have 4 to the 3rd, which is 64. P to the 15th. Q to the 3. Come on, match up with 1. What do we got? B. Ooh, I had a quick heart attack there. I didn't see it. But that looks like our answer matches up with B. All right, good job. And then to talk about two ideas here, 0 and negative exponents. The first one, real easy. 0 exponent property. Any non-zero number raised to the 0 power is equal to 1. And that's sort of just a mathematical definition. We just say a to the 0th equals 1. That's our unit. And nice, okay? So that means all of this mess, this wonky mess right here, because it's raised to the 0th power, it's just 1. Boom, easy. So that's simplified. Simplify n to the 0th n cubed divided by n squared. Well, n to the 0th is just 1, so you now have 1 times n cubed over n squared. Quotient property, the bases here are the same. Subtract, you're left just n to the 1st, which is n. Don't write that 1. It's just implied in the answer. Makes it nice and neater. Means you know what you're doing if you don't write the 1 at the end. So n. Whew, okay, good. Can we finish off strong with some negative exponent property? Okay. So far we had just positive exponents, and that's nice. But we come across negative exponents a lot. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Also, the reciprocal of a to the negative n is a to the n. What? Okay, so anytime I see a negative exponent, if an exponent is negative, what I like to say, put it on the other side of the fraction. Okay? Because it's not always going to go to the bottom, or because sometimes it goes up. You know, put it on the, let's say, move it to the other side. Move it to the other side of the fraction. That means if I have x to the negative 4, it's going to become 1 over x to the 4th. Because, right, x to the negative 4, that's over an implied 1. So I move it to the other side of the fraction. So I'm left with the 1 up top, because it's kind of 1 times x to the negative 4. And the x goes down low, and it becomes a positive exponent. If I have 1 over b to the negative 3, well, move it to the other side of the fraction to make that exponent positive. So it's b cubed. Simplify. X to the negative 4, y to the 9th, the z to the negative 6. When we're simplifying and we're going to start throwing in all different things, all different properties into our problems, deal with the negative exponents first. That often helps things out. So x to the negative 4th, well, that means my x goes down low. Y to the 9th, nothing to do there. All right. Z to the negative 6. Well, throw it to the other side of the fraction, and it becomes positive. So I have z to the 6th. Let's see, any variables with the same base that we can combine more? Nope. Any negative exponents? Nope, we dealt with that. So there we go. Simplified. Whew. Big Daddy here. Looks like we got division going on. So we'll look at each term individually. So first, 36 divided by 9. There we don't have same bases, so it's not like we're subtracting exponents. I mean, we don't even have exponents. This is just division. Simplify a fraction. 36 divided by 9 reduces to 4 over 1. Well, we don't need to write the 1, so I just got a 4 up top. Moving on over to my x's. X to the 5th divided by x to the 4th. So division. So subtract the exponents. You're left with x to the 1st. And let's try the y's. Y to the 8th over y squared. Subtract, so I have y to the 6th. And then lastly, the z's. Z to the 3rd divided by z to the 6th. 3 minus 6, what is that? Negative 3. Okay, we dealt with all those different variables, but now I still have a negative exponent in my answer, so it's not simplified yet. So I'm going to rewrite this one last time. 4x y to the 6th, and to deal with that negative exponent, send it to the other side of the fraction, z to the 3rd. All right, good job. 4 big properties there. Remember your zero power property. Anything to the 0th power is 1.